Okay, mutually exclusive versus independent projects. So if we have an independent project, it doesn't affect us. Accepting or rejecting one doesn't affect the other. Uh, we, you know, it has to meet our acceptance criteria. We've talked about so talk about it, NPV and how that is by far the superior criteria, but the others still may still see them. Um, Mutually exclusive projects, only one of two or more projects can be chosen. So say the example here, acquiring an accounting system, building a new factory, those sorts of decisions. What the decision is typically exclusive. We evaluate several alternatives and we pick the best alternative. uh, Rank all the alternatives, select the best one. So multiple internal rates of return. I mentioned this previously. This case we have initial cash flows of our cost of $200, then inflows of $200 in the first year and $800 in the second year, and then a disposal cost of $800 in the last year. Kind of an unusual cash flow, but it works for the example. So we have in this case the IRR is either 0% or 100%. So, and that is simply as a result of having these multiple negatives. So, how do we know which one to use? So, what was done to make IRR a better choice, or eliminate multiple IRRs, you calculate all the cash flows, the present value of all the cash flows using the borrowing rate, calculate the net future values of all inflows using the investing rate, find the rate of return that equates to these values. So benefits are that it provides a single answer and specific rates for borrowing and reinvestment. Scale problem. So, would you rather make 50% or 100% on your investments? So, if the 100% return is on $1, and then the other 50% return is on $1,000, you would obviously prefer to earn 50% on $1,000 as opposed to 100% on $1 investment. So this can be the case with projects of different size. So this is one of the big reasons why NPV is preferred, because it doesn't matter necessarily the size of the project. It's the increase in the value to the firm. So timing problem. So they've got project A and B here. They got project A is the cash flows are front end loaded. You see the $10,000 up front here, and then the project B, the cash flows are they are backloaded. So the so what that means is we have a crossover rate. So we've got project A. This is the NPV profile of project A. At low rates, project B is actually more valuable than project A, so it creates more value. But as rates go up, project A becomes more valuable because the cash flows occur sooner. So this is what we talk about when we refer to the timing problem. So, okay, so we can calculate the crossover rate with by taking a couple of simple steps. What we do is, there we go. Whoops. There we go. All right. What we're going to do is we can subtract project B from project A. That's what these cash flows are. So initial investment's the same. So 10,000 negative 10,000 minus 10,000 is 0. 10,000 minus 1,000 is 9,000. 1,000 minus 1,000 is 0. And 1,000 minus 12,000 is negative 11,000. And we take the IRR of this project. You could do it the opposite way too. It doesn't. The order doesn't matter. You just have to go. When you're subtracting, you do the same calculation each time. So that will give us the IRR crossover rate. So that's the point where the NPVs of both of these cash flows are 0. So so it doesn't matter which one you calculate. You only have to calculate one. But tells you the point at which. So at any point above 10.55%, we're going to prefer project A, and at any point below that rate, we're going to prefer project B. So depending on the required rate of return for that project.